Greetings to all learners. My name is Naveen Yadav and I am Faculty of Physics at SRN International School, Jagatpur, Jaipur. Today I am taking the topic Coulomb's Law from the chapter 1, Grade 12 NCERT. Reference book is Fundamental of Physics by Resnick, Halliday and Volker. In this topic, you will come to know about the interaction of the charges, that is, force between the two charges. Coulomb's Law. If two charged particles are brought near each other, each of them exert a force on the other. If the particles have charge of the same sign, they repel each other. That is, the force on each particle is directed away from the other particle. In this case, if the particles are free to move, they will move away from each other. What happens if the particles have charge of the opposite sign? In this case, the particles attract each other, and if free to move, the particles will move closer to each other. This force of repulsion or attraction between two objects due to the nature or sign of their charges is called electrostatic force. This equation giving the electrostatic force for the charged particle is called Coulomb's law. So, according to Coulomb's law, the magnitude, that is the force capital F of the electrostatic force exerted by one point charge Q1 on other point charge Q2 is directly proportional to product of the magnitudes Q1 and Q2 of the two charges and inversely proportional to the square of the distance r between them. Mathematically, F is equals to K Q1 Q2 divided by R square, where this K is a proportionality constant whose value in SI unit system is 8.99 into 10 raised to power 9 Newton meter square per Coulomb square. The electrostatic force is directed along the line joining the two charges. If it is attractive, the charges have unlike sign, and repulsive if the charges have like sign. Let Q1 and Q2 be 2-point charges separated by a distance r in the vacuum as shown in the figure. Then, according to Coulomb's law, magnitude of the force on the charge Q2 due to Q1 is F21, and this is given by F21 is equals to K Q1 Q2 divided by R square. So F21 is always directed from Q1 to Q2. That is, F21 is equals to F21 magnitude multiply with a unit vector, where this unit vector is vector divided by its magnitude. Therefore, we can write it down as F21 is equals to K Q1 Q2 divided by R square multiply with R vector divided by its magnitude. So the equation will become K Q1 Q2 divided by R cube multiply with a unit vector, a vector, where this K is equals to 1 upon 4 pi epsilon naught. This is the proportionality constant, where this epsilon naught being the permittivity of the free space. If the charges are placed in a medium other than the vacuum with absolute permittivity epsilon, then we have F is equals to 1 upon 4 pi epsilon naught Q1 Q2 divided by R cube multiply with R vector. So here permittivity is measure of how an electric field affects and is affected by a medium. For conductors, epsilon naught is equals to epsilon r, and epsilon r is infinity, where this epsilon is called the relative permittivity or dielectric constant of the medium. The numerical value of this epsilon is 8.85 into 10 raised to power minus 12 Coulomb square per Newton meter square. So, the value of 1 upon 4 pi epsilon naught is approximately equals to 9 into 10 raised to power 9 Newton meter square per Coulomb square in SI unit system. So, the same Coulomb's law can be drawn or can be derived in the vector form. For this, let us 2-point charges Q1 and Q2 be located at point A and B in vacuum or the free space. Okay, so mark there the distance. The distance of charge Q1 is OA and it can be R1 vector, and the position of charge Q2, that is OB, and this is equals to R2 vector, be the position vectors of A and B, where this O is the origin of the Cartesian coordinate system. Okay, so according to Coulomb's law, force on the Q2 due to Q1 is F21. This is equals to 1 upon 4 pi epsilon naught Q1 Q2 divided by R2 minus R1. This R2 minus R1 is the distance between the charge Q1 and Q2. And similarly, the equation for the force on the Q1 due to Q2 will be given by F12 is equals to 1 upon 4 pi epsilon naught Q1 Q2 divided by R1 minus R2 cube multiply with R1 minus R2. So above two equations, they are opposite of each other. So F21 is equals to negative of F12. So from this equation, we can conclude that the force exerted on the charge Q2 by the charge Q1 is equal in magnitude but opposite in direction to the force exerted on the charge Q1 by charge Q2. So students, in this lecture, we have learned about the Coulomb's law and Coulomb's law in the vector form. Students, keep learning, keep signing, stay home, stay healthy. God bless you.